Go! Good afternoon, everyone. We are Group 3 and we are going to talk about comparison of liquid and vapor curve. So before, let's talk about liquid and vapor. So liquid is the nearly incompressible fluid that conforms the shape of its container, but retains a constant volume independent of its pressure. So we all know that liquid is the one of the fundamental state of matter. Diba?
Yes.
So, masa kailangan ng matter?
Solid.
Plasma.
Base.
Yes, very good. And liquid is the only one state of matter that has definite volume and but don't have fixed in shape. So, vapor is a substance that gaseous phase. So, at a temperature lower than its critical temperature, which means vapor can condense to a liquid. So, the difference between liquid and vapor is composed of molecules.
Can I have your attention?
Yes, ma'am.
Okay, so we can see the heating curve. So teacher, what is the purpose of heating curve?
Yes, teacher.
The heating curve graphically represents the phase transition of a substance undergo as heat added to it. So this y-axis indicates the temperature, while the x-axis is the heat absorption. So as we can see, the temperature in this line graph is increasing, and the temperature and the heat absorption is proportional to each other. So as the more heat added, the more higher temperature it is. Understood?
Yes.
Oh. So as you can see on the graph, there is a phase transition of a substance. For example, water from ice, solid, and if the temperature increases, it will change its phase to liquid, and then this flashes part of the curve represents the constant temperature. So as the liquid reaches its boiling point, the temperature is constant until it changes its phase again into vapor or gas. So the temperature again rises, as well as the heat added for the temperature to increase. So liquid reaches boiling point at 100 degrees Celsius temperature, while when solid is melting, the temperature at is constant. So as we can see in the graph earlier, so from the line graph, the temperature is constant when it reaches to 100 degrees Celsius. So vapor or gas reach 140 degrees Celsius, and the temperature of the liquid is constant while the liquid is boiling. So in the vapor, we can easily conclude that vapor is transition of a substance. For example, water from ice, solid, and if the temperature increases, it will change its phase to liquid, and then this flashes part of the curve represents the constant temperature. So as the liquid reaches its boiling point, the temperature is constant until it changes its phase again into vapor or gas. So the temperature again rises, as well as the heat added for the temperature to increase. So liquid reaches boiling point at 100 degrees Celsius temperature, while when solid is melting, the temperature at is constant. So as we can see in the graph earlier, so from the line graph, the temperature.
Now I am going to discuss about the cooling curve. Cooling curve is a line graph that represent the change of phase of matter, specifically from gas to liquid or liquid to solid. So These the y-axis represent as temperature, and this x-axis represent as the the heat decreases. Then a substance will start out in the gaseous state, and when the substance loses enough heat energy or cool enough, it will hit the condensation process. And when it hit the condensation process, the constant. And then Latin heat.
Latin.
Latin.
James Zaspa will sum up everything.
So, as we see, it is a latent heat of selected material. So, see, aluminum has 399 latent heat diffusion. So, 130 grams balik sa latent heat diffusion. Bale, dito point out.
Point J.
Point?
Yes, J. I-divide mo nimo J.
Dira.
Ay, rawa kasi mag-direct.
80,000 divided by 4184. Answer ka, 19.12. Sakto?
Ay, ang bala.